In this video, we're going to take a look at annuities. In this first example, we have find the future value of an ordinary annuity of $80 paid quarterly for 3 years if the interest rate is 8% compounded quarterly. So let's take a look at the formula we're going to use and go ahead and identify all of our numbers that we need. So our future value of annuity, so future value, or our book calls it S, is equal to R, which is the payment size, times 1 plus I to the n minus 1 divided by I. And remember that I is equal to R divided by M, where M is the amount of compounds there are. So in our problem, R is equal to 0.08, and we're compounding quarterly, so M is equal to 4. So I is going to be 0.02. And R is our payment, so we have $80. And N is equal to the years, which is 3, times the compound. So we have 12 payments total that are going to be made. And now we have everything we need to plug into the formula. So we have future value, or S, is equal to 80 times 1 plus 0.02, or 1.02, raised to the n, minus 1, all divided by I, which is 0.02. And when we multiply everything out in our calculator, we find that we have 1,072.97. So if we were paid $80 for 3 years at 8% compounded quarterly, we would have $1,072.97 at the end of 3 years. In this next example, it says, with a present value of $135,000, what is the size of the withdrawals that can be made at the end of each quarter for the next 10 years if money is worth 6.4% compounded quarterly? So for this problem, we're going to need to use the present value of annuity formula, which is present value of annuity, or our book calls P, is equal to R times 1 minus 1 plus I raised to the negative n, all divided by I. So again, let's write out everything that we know. We know that I is equal to R 0.064 divided by M, which is 4 because we're compounding quarterly again, which comes out to 0.016. N is the years, which is 10, times our compound, which is quarterly, 4. So we have N is equal to 40. And R is what we're trying to solve for. So R is our unknown. And in this case, P is equal to 135,000. Because they told us that we have a present value of 135,000. So that's our P. So now let's write everything in there and solve for R. So we have 135,000 is equal to R times 1 minus 1 plus 0.016 is 1.016 raised to the negative n, and n is 40, so negative 40, divided by 0.016. And when I multiply everything out and divide, so I have 135,000 divided by everything that was in the brackets, is equal to R, and and R is equal to $4,595.46. So that means every quarter we can withdraw $4,595.46 if the present value is $135,000, and we can do that for 10 years. In this last example, we have $2,500 is deposited at the end of each quarter in an account that earns 5% compounded quarterly. After how many quarters will the account contain $80,000? So here in this problem, we're solving for n. So now let's write down everything else we know. We know that the future value that we're looking for, or S, is equal to 80,000. They tell us that right here, 80,000. And I, which is equal to little r, which is our rate, 0.05, divided by the compound, is equal to 0.0125. We know that capital R, the payment, is equal to 2,500, and we got that from the beginning of the problem. And now let's plug everything we know in and solve for n. So we know that we have 80,000 is equal to 2,500 times 1 plus our I, or 1.0125, raised to the n, and we're solving for n, minus 1, all divided by I, or 0.0125. And then I'm going to divide both sides by 2,500 to get rid of our 2,500 out front, and multiply both sides by 0.0125. Or you could also think of it as multiplying this entire thing by 0.0125 divided by 2,500. And that would clear 2,500 and 0.0125 from the right side of our equation, and we multiply that number by 80,000. And when we do, we get 0.4 is equal to 1.0125 n minus 1. Add 1 to both sides. And now I'm going to take the ln of both sides to get the n out of the exponent. And now n is equal to the ln of 1.4 divided by the ln of 1.0125. And when we do that, we get approximately 27.09. So that means it's going to take us 28 quarters to get our future value up to 80,000 if we're depositing 2,500 at the end of each quarter in an account that earns 5% compounded quarterly. And that's our video on annuity.